downloading earthquake data, visualizing it, and running inference on a machine learning model in order to predict volcanic eruptions. We will be doing all of this using Shapelets. Let's do some imports. In order to use Shapelets, we will need the following imports and some other imports that we will be using in this data app. You can create your data app by calling init session, indicating the credentials that you want to use to log in into this data app. And you can also share your data app with others, and they will be able to log in the network using these credentials. Now you can create the data app by calling the data app constructor and indicating a name and a description. In this data app, you will be using two custom functions, and for every custom function that you use, you have to first register it before using it. The first custom function is called build map, and this function takes care of building the visualization of the earthquakes that will be shown in the data app. And also we have a compute probability custom function which takes the earthquake data, feeds it into this machine learning model, and obtains the probability of volcanic eruption. In the data app, you can create different elements, for example, a markdown element in order to create a title for the data app, or an image if you want to make your data app look nice. In this case, I'm using a local image file. And you can add more markdown elements in order to add an introduction to the data app describing what you're going to be showing in this data app, some discussion about earthquakes, or in this case, an invitation to the user to select a time period to search for earthquakes. And now it's the time to download all the earthquakes recorded to the date in the Spanish National Geographic Institute servers. We will be doing this by placing an HTTP request into the servers of the National Geographic Institute, and in order to execute this request, we need to provide several parameters. In this case, the latitude and longitude ranges of the geographical area in which we want to search for earthquakes, and also the starting and end date of the records that we want to retrieve. In this case, we are choosing as start date the oldest possible date, and as end date the date of today. So in this case, we will retrieve all available records in this within these coordinates. So let's go ahead and implement this function. So we can go up here and create the header and a description for the function, and we can also create a variable for the URL and the payload that we will use to place this HTTP request. Basically, this depends on the server you are retrieving data from. So this request is specific for the Spanish National Geographic Institute, and if you want to use other data provider, you will have to adapt this this data to your specific provider. In this payload, we have all the parameters that we will need for this request, and we also indicate that we want to receive the data in TXT format. In order to build this HTTP request, we will be using another function called Encode multi-part form data. This function falls out of the scope of this data app and out of the scope of this use case, so I will not go very deep into it, but you can take a look at it if you are interested. So once we have the body and content type, in order to execute this request, we can go ahead and execute it. So we use the requests module and we place this post request using the URL, the body, and the content type that we just obtained. Once we have the response to this request, we can convert it into a data frame. We first have to decode it, and then we use this pandas function in order to convert it to a pandas data frame. We can also take the field that contains the date and convert it into a date time series, indicating the format of the date in this field. And we will also build a key that will be shown to the user in order to select an earthquake later on. So this key contains the date of the earthquake, the time of the earthquake, the localization, and the magnitude. And once we have this data frame with all this information, we can simply return it. Okay, so now we have all the earthquake records into this pandas data frame, and what we want to do is to convert it into a Shapelets data frame. And we do this by calling the client.createDataFrame function. We add the pandas data frame and we provide a name and a description, and this converts the pandas data frame into a Shapelets data frame. And we will be using this later, so it's convenient that we do it at this point. And we continue creating the rest of the elements in our data app. We will add now the 2 date selectors that will allow the user to select the date range. So a starting date, and we set it to January 1st, 2019, and an end date, and we set it to January 1st, 2020. We also create a button, and when the user hits this button, we want to call the build map function. So we're going to call the build map function, and we pass our Shapelets data frame and our date ranges, and this function will return the image that we want to visualize. And we pass this variable map as a function of the onClick, as a parameter of the onClick function, so that when the user clicks, this map variable gets updated. We will also place all these components in the data app, and now we can go ahead and build this function. So let's go up again, and let's go more in depth into the build map function. So this build map function is actually, we will put it here, it's actually a custom function, and it takes a Shapelets data frame containing all the earthquakes recorded, and it also takes the starting date and end date as inputs. So basically what we want to do here is to reduce the records in this data frame to the ones that are within these dates, and then take the geographic information, place it into a map, and then return the map as an image. So since we're doing these operations inside a custom function, we need to put all our imports here. So these are the imports that we will need in this custom function. So datetime, plotly, we will use plotly in order to build the map. Also matplotlib and IO. So again, here we convert the Shapelets data frame into a pandas data frame. And then we extract the earthquakes within the dates provided by the user. And we do this very easily using pandas and providing the dates that the user has selected. Once we have the records of the earthquakes within the dates selected by the user, we will use the following plotly express code in order to build the map visualization. So here it is. So basically it's a scatter map box with the latitude and longitude indicating the latitude and longitude of each of the earthquakes, and well, some other options like where is the center of the map and the amount of zoom that we want for this map. These are the main parameters. Once we have built this map, we can use a bytes.io object in order to convert the map into an image. And if we do it this way, we avoid having to store the map into a file and then reading it. So we just use the memory to feed this map data into an image. And we now create a matplotlib figure and display the image into the figure. And once we have this figure, we return an image based on the content of the figure. Okay, and with this we have finished building the build map custom function. And now the data app will be capable of creating this map once the user hits the show earthquakes button. Okay, so we can continue and build the rest of the data app. And for that, we want to first add another markdown element where we explain a little bit more about volcanic eruptions and describe the model, the features it relies on. And we also invite the user to pick an earthquake in the list and thus obtain the probability of eruption for that specific earthquake selected. So for this, we have to create and place a selector that will allow the user to pick a specific earthquake. And we will use the key column in the data frame that we created earlier. We will turn this column data into a list, and this will be the options of this selector. And we can also add a title to it to let the user know what he or she is choosing. Once we have placed the selector into the data app, we simply create a button that will trigger the model inference. We're going to load the model. The model is stored as a pickle file locally. So we want to load it, and in order to feed it into our custom function, we will put it inside a capsule. And this is the usual way of passing information into custom functions. Mainly passing models or similar types of data. Now we call the function compute probability. And this function will take the earthquakes data frame with all the earthquakes, takes also the selection, the specific earthquake selected by the user, and also takes the capsule with the model that we'll be using for running the model inference. So we want to assign the action of the button to this function. So we take with the output of the function and pass it to the onClick function of the button. And in this way, when the user presses this button, this node will be updated and this function will be executed. And now we simply have to place a label with the result of the inference, and we register the data app. And so the only thing we have left is this compute probability function, and we will now go deeper into it and explain how to build it. So let's go up again, and we can build this custom function here, for example. So this function compute probability takes the data frame containing all the earthquakes. It takes the key of the earthquake selected by the user, and also a capsule with the model. And the output of this function is the string that will be shown to the user, indicating the probability of eruption. Okay, we add a short description. We need to import NumPy in this custom function. And we first want to convert the Shapelets data frame into a pandas data frame. We want to obtain the year and the event ID of the earthquake selected by the user. So since we know the key, we can search in our data frame that contains all the earthquakes, search for the one with the corresponding key, and then extract the year and the event ID for that specific earthquake. And in order to obtain the earthquake data, we have to download DAT file from the servers of the Spanish National Geographic Institute. So we simply create this URL variable, and we pass the date and the event ID to it, and this will point us to the specific file that we're interested in for that specific earthquake. And next we are going to read the earthquake file. So we will use a try in case there is some problem connecting to this server and obtaining this file. Once we download the file, we are going to convert it into a pandas data frame 2. We're going to build the features that are required for running the prediction in our model. In this case, we use the amplitude, minimum amplitude, skew, and kurtosis of the amplitude. And we also build another feature called normalized amplitude. This is basically the amplitude of the earthquake divided by the distance to the point where it was measured. So we use the kurtosis. We use the kurtosis and the standard deviation of this normalized amplitude. Once we have our features, we're going to min-max scale them. in order to avoid scale problems. And well, this data is basically obtained from the model development stage. Once we have our scaled features, we simply feed them into a model and return the probability of the eruption. And in case we cannot obtain a probability value, we will simply return a string indicating that there was an error and let the user try with a different earthquake. And with this, we have finished our data app. So we can simply run this data app. And now in the browser, we can log into the data app by using the credentials that we indicated in the call to init session. And our data app is here. We can see the title, the image, the markdown objects, and here we can select our dates. For example, we will search for all the earthquakes that happened in year 2020. And here is our visualization. We can also check, for example, all the earthquakes that have happened until today. So October 19th, we can see that there is a huge amount of earthquakes in the last few months. And here there's another markdown with the discussion about the relationship between earthquakes and volcanoes. And we can pick an earthquake from this list. These are all the registered earthquakes that we downloaded. This is the key. We can simply pick one and compute its probability of eruption. There is no phase data for this one, so let's search for another one. So for example, 6.47% of probability for this one. And we can choose different earthquakes and measure their probability of eruption. And that's it. Thank you for watching this video.